Good evening, everyone, and welcome to the next edition of With No Expense Spared, Mr. Dwight Doodles. This little video tonight comes from B7. This is on paper 2 biology, and it's the required practical that's split into two that is called sampling. We've got a little video on here called B5 on the ruler drop test for reaction time. This is sampling. And there's two types that I'm going to talk about. I'm going to talk about a random, and then I'm going to talk about the opposite of random, which is systematic, where you've got a method on what you're doing. It's specific, it's systematic, and we've got random. Let me introduce you to my beautiful garden, ladies and gents, and look at these buttercups growing beautifully in the summer. Now, what this required practical asks you to do is take a random sample and say how many buttercups are growing within this grass lawn. Now, someone somewhere could go and count every single individual buttercup, but that's not very efficient. So this first part of this required practical is about how we can take a sample, a time-efficient sample, and then estimate using our samples to guess the number. Well, it's not guess, it's an estimation of the numbers within this lawn. So the first few things we need to do, and again, the good news about required practical is what I'm about to go through will be the same on every single question. It will just need to be adapted to that question. Got myself a little friend here. This is Ronnie the ruler. Now, I'm going to measure down the side here, and it's going to say 12 centimeters in its length. Now, what I'm going to do to make this simplified is I'm going to take away the centimeters and pretend this is 12 meters. I'm going to take my little friend here and I'm going to measure across the top because I need to get myself an area, and that works out at 19 meters. So 12 down, 19 across. First thing I need to do then is I need to work out the area of the lawn I'm about to sample. So here's maths part 1. What I'm going to do is I'm going to get my little calculator. Here it is. I'm going to put 12 times 19, and that's going to give me that area of 228 meters squared. Okay, that's step 1, calculating the area of our random sample. Then I'm going to introduce you to the next protagonist in this story. This is called a quadrat. It is a piece of metal. It is a square. What is inside the square is what we are going to do with our samples. So the first thing I need to do is I need to know how many of these quadrats, not the outer part, but the inner part, would fit within our sample of 228 meters squared. So our quadrat is, let's say, 2 by 2. 2 meters by, it is actually 2 centimeters. So we'll go 2 by 2. That makes it 4 centimeters squared. But obviously, for the purpose of ease of understanding, we're going to go with 4 meters squared. Rather large quadrat, but just work with me on this. I now have my area. I now have the size of my internal area of my quadrat. I now need to know how many of those fit in there. So what I would then do is go 228 divided by 4, because that's the size of the quadrat. Let's bring up the old calculator again. Here she blows. Divided by 4 equals 57. That means 57 of those will fit in there. Okay, that's the first part of the random sampling. Now, what I need to do is I need to take 10 random samples within there. Now, what you could do is you could just throw them on. I'm going to say these words over and over again shortly. But the problem is that we're talking a big area here. And if this is Mr. Dwight stood down here throwing his quadrat, I might not be able to reach the back areas of this space because it's 228 meters squared. And I could move around, but then that would suggest there's going to be less samples taken from the middle. And all this does is I need a system that removes any bias of throwing it in the same places all the time. So what you'll see around the outside are numbers. And this is our grid system, our coordinate system to select our random samples. So what I have to do next is, because my quadrat is 2 by 2, I'm going to go across by 2, and then I'm going to make my grid system, and then I'm going to go down by 2, and then down by 2, and down by 2, just so you can see what's happening, purpose of ease. And now what's happening is I'm making myself a grid system. So you won't know what Blue Peter is, but in the fashion of Blue Peter, here is the grid system. And so what would happen next, if this was A, B, C, D, E, and F, when you pick your random samples, your teammate, your partner, your colleague would go B3. There's B, there's 3. There we go. I'm going to take that sample. Now we can see there's 1, 2, and a little chap poking through. If we believe that that is more than 50% of the buttercup poking through, we include it. Because I'm closer than you, I think that isn't. So I'm going to count 2. So what I then do, obviously you'll draw a table with a pencil and a ruler, but time is against me. In here, it would be sample. And that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And this would be number of buttercups. So in the first sample I've got is 2. I then get my colleague to pick another random coordinate, F10. There's F10, down there's another 2. And then you'd fill in by taking the random samples all the way through. Let's say I've got 10. Okay, that's not great, but we'll go with it. And then 2. And if I add up all of those values and divide by 10, I've got myself a mean average. So I'm going to say, when I add all of these up and divide by 10, that's 2, 4, 8, 12, 14, 16, 17, 18, 19, 20. Well, there's 10. So that gives me a nice average of 20 divided by 10 gives me 2. 2 buttercups on average in the 10 samples that I've got. Let's go back here, ladies and gents, for the math. The average in each quadrat is 2. I know that there are 57 quadrats that fit in this grid system. So what I have to do, let's go 2 times 57. That means 57 times 2, because that's my random sample. And if my math serves me correctly, I would then count 114 as my estimation in there. Now, I do believe there are 103, so I am out slightly, but that's okay because this is an estimate. That's the random sampling. And the key words here is we can't have bias. And that's why we have a grid coordinate system to pick our random samples. We don't throw. Bias always has to be 10 samples. Now you can go back and rewatch this to help you answer those questions. Now that's random. That's random. This is the opposite. This is my garden in Stamford. No, it's not really. But this is different. Now, if we were going to do random sampling, we've got a river running through. We've got trees all over the place. We've got a little path here. This is different. This is systematic sampling. There is a system to this. And the difference being, the question we're going to ask is, how do biotic and abiotic factors affect the distribution of plant species as you move away from the river? So this time around, we get a tape measure, a meter tape that's about 30 meters long. And what we do, we have ourselves a little system. So we draw a line, and let's say that line is 10 meters. We want to look at how does the distribution of plant species differ along this line, if it is a living factor, bio, or a non-living factor, abiotic. So this would be disease. This would be other animals that were predating on flowers. This would be water availability, oxygen availability, light availability, shade availability, and so on and so forth. This time around, you place your quadrat every 1 meter systematically and do exactly the same thing. You count the number of plant species within each of those, or the distribution of plant species, and you look to see how it changes as you move from the river. This is called a transect. Oh, I'm going to make sure I spell this right. Transect. And you would have not just 1, 2, 3 would be a minimum. That's an E, by the way, and that's a C. And then again, every meter on the same side of the meter tape, or the tape measure, we put our quadrats on the right every 1 meter, and we count again the number of species, and we would be able to see the biotic factors. This river, huge quantity of water, abiotic. How would it impact the plant species as we move along the transects? Not random, systematic. Thank you very much for listening, ladies and gents. Please use this for your homework. If you like, what do they say online? Subscribe to something or other. Thank you.